Alrighty, in this video, I'm covering, oops, I meant to use a laser pointer on that one. I'm covering relations and functions, alright? I use that for 3A. Alright, so this lesson isn't terribly difficult, but it has a lot of vocabulary to it. Like a lot. Alrighty. So, a relation is a relationship between values. Okay? You guys are used to seeing relations as a bunch of ordered pairs. So like the ordered pair, for example, x, y, talks about how x is related to y. We're describing those relationships. Now, we're trying to look at a special type of relationship, which is called a function. Right? A function is a relation in which each x value has exactly one y value. One of them. Okay? So, just so you know, in this set of notes, if you have two colors, you really would love that in your notes. It will help you with seeing the patterns so much easier. Okay? So, it's important for us to be able to recognize if something is a function or not, because as we move forward in math, every single rule that we are applying requires the relation that we're looking at to be a function. Okay? So calculus, trigonometry, everything from here on out, geometry, requires you to have a function. So we're practicing figuring out if something is a function so that we know that our rules that we use later in math work. Okay? So we're going to describe two things, domain and range. Now our next lesson is describing domain and range, so it's not the main focus, but I mentioned the domain and range, and I put it in the notes because I need you guys to really learn domain and range. It's a real big deal in math, so I'm making sure to touch on it here because it's convenient, and then it's also in our next lesson. Alright, so the domain is all the input numbers. It's all the x values. I'm using red to describe those. And the range is the set of all the output numbers. Oh, I guess I should put S's on these. Outputs and inputs. Anyway, the range is y values. Okay. So there's technically 6 ways, which I thought about in our last video, but whatever. There's 5 different ways that we represent relations and functions. Okay, so I have them separated into 2 separate groups here. The first group is called discrete, and the second group is called continuous. So discrete graphs look like a bunch of individual points. So like if I were to graph them, they would graph like this, like a scatter plot. Okay, so when you have discrete functions or discrete relations, what we're looking at is things like ordered pairs, tables, and mapping diagrams, because those list off a bunch of just points, essentially. Here it's actual ordered pairs. Here each row is an ordered pair, and here each arrow is an ordered pair. So that's why they're called discrete, is because it's just a bunch of dots. Alright, so in an ordered pair, right, that goes x, y. So I'm highlighting all my x's red and all my y's blue. So my domain here is -1, 0, and 2. And my range is 2, 5, and 7. And we put these little curly brackets around it just to say, like, hey, I'm talking about these numbers. Okay? It's called a set. So I'm saying it's this set of numbers. And that's the entirety of it. So for this to be a function, what I do is I'm mostly looking at the x values. We're making sure that each x is only married to one y. So like -1 is only married to 2. 0 is only married to 5. And 2 is only married to 7. So this one is a function. Now, if I wanted to figure out like an example of what would not be a function, say I had another ordered pair, 0, 3. Do you see how the 0 is repeated? So 0 here is married to 5, and 0 here is married to 3. So that would be a problem because that input has 2 separate outputs. So what are you looking for? Look for repeated x's. And those are called x values. They're not x-intercepts, x values. Okay? So on a table, all right, usually the left column is x's. Sometimes people get a little weird with their tables. They don't think about stuff. So you always want to check the header on your table before assuming it's x then y. Because some people will try to mess with you, which is rude. So the domain on this table, okay, is all the x numbers. Now when you write out the domain here, it needs to be in counting order. So I made sure that the -2 went first. And then do you see how the 3 is repeated there? I only list it once. Same thing with the range. So I'm putting it from smallest to biggest with no repeats. Now this is not a function. The reason why is because right here, that 3 is repeated. The 3 here is related to 1, and the 3 is related to 6. So again, this is a look for repeated x's situation. And again, the repeated x values, not intercepts. So because 3 is tied to 2 separate numbers, it's not allowed. That's like if you go to a vending machine and you put in your money and you type in the little code, you choose option 3, and sometimes you get option 1 and sometimes you get option 6. Like, when you hit that 3 button and you are really pining for a Snickers bar, you're going to be upset when some gummy snacks fall out, right? So, like, that's why it's a problem. You need to make sure that the button that you're hitting is going to distribute the snack that you want, essentially. Okay, so this is called a mapping diagram. Mapping diagrams are annoying because they don't label x and y. Technically, here's x, here's y. And it's always x is on the left and y is on the right with mapping diagrams. So often they don't bother labeling them because we assume you to know it. I don't really know why teachers still teach mapping diagrams. The only time I've ever seen a mapping diagram is in this discussion right now about functions and not a function. Never again have I seen it. It's one of those old archaic things, I guess. So your domain is the left circle, right? Because that's all your x values. And mapping diagrams are really easy because the domain's actually already like listed for us. It's already in counting order and it never shows repeats. So we just kind of copy down the bubbles, and that's really nice, really convenient. Now the arrows that you see here, these are actually describing ordered pairs. So like this arrow is the ordered pair -7, 2. Or this one is the ordered pair 3, 1. Okay. Now is this a function? So we're looking at these x values and making sure they only have one partner. So -7 is only married to 2. 0 is only married to 2. It's okay if they're married to the same number. We don't care if y is repeated. We just care that these guys have a relation with only one number. Something that would make this not a function, say for example this 0 had 2 arrows leaving it. This would create not a function. But right now, it is a function. So I'm going to add a note. Look for more arrows leaving x. I don't know. So more arrows leaving a single x value. That would be the problem. Okay. So those are our discrete functions. Again, we just list off the numbers to describe domain and range, and you look for repeats in the x's. Are the repeats listed off as ordered pairs? Are they repeats in the table? Or are there arrows leaving repeatedly from an x number? Now the other type of function is called continuous. So continuous graphs look like smooth curves or lines. So like, if I were to try to draw it, what I'm saying is you wouldn't pick up the pencil to draw it. All right, now in order to tell if something is a function, there's a certain test that we use called the vertical line test. And so what the vertical line test says is if you take your pencil and you pass it over the graph, what we're looking for is will the graph only touch it once, ever? So for example, on this one, this is a function because no matter where I draw a vertical line, it's only touching that line once. Okay, so I'm going to write the word touches once here. Now for something to not be a function, if you draw a vertical line, even if it's only in one spot, if ever the vertical line touches the function twice or more than once, could be 3 times, could be 4 times, could be infinitely many times, but if ever the line touches more than once, it's not a function. So here I'm going to say touches more than once. Alrighty, so let's take a look at this one. This graph's kind of hard to read, so we're just going to accentuate some stuff. So here's our x-axis. Here's our y-axis, and I find if you kind of darken it, it makes it a little easier to see. Okay, so you'll get into how to write this domain and range a little bit later. But let's just talk about what you see. So the domain on this goes as far left. So the smallest x value that could be here is right here. That's at -4. And the farthest to the right that this circle goes, here's the most rightest point. That's at 1. So there's our domain. Our range on this, the lowest this circle goes is right here. That's at -2. And the highest that the circle goes is 3. So there's our domain and our range. Is this a function? That's what I really care about. So I'm going to draw a vertical line on here. Ooh. Do you see how it's touching twice, here and here? That means this is not a function. Nay. And like I said, the domain and range, you guys will learn it in the next lesson. So it's okay if you don't understand totally how we got there. Just remember domain's left and right. Range is down to up. No biggie. Now with equations, you can't see all the information about them. So usually you have to graph them, which is really annoying. Now this one's a linear function, right? This is basic. Shouldn't be too bad. So if I think about y equals mx plus b, right? Here's our b. So that's down at -1. And then, I wrote that ordered pair in a bad spot. And then it has a slope of 1. So it's a line that's going to look like that, okay? So for domain, this goes to the left forever, and it goes to the right for forever. So I use this funky letter R. That means all real numbers. That's how you say forever and ever. The range, it goes down for forever, and it goes up for forever. So I'm also going to use this funky R, which again means all real numbers. Okay. I'm not worried about domain and range as much in this lesson. You guys will learn a little more about it in our next one. But is it a function? So anywhere that I'm drawing a vertical line, do you see how the orange line only touches each vertical line once? So this is a function because it passes the vertical line test. So there we have it, friends. That's how to tell if it's a function or not. Okay, so on equations and graphs, you have to use the vertical line test. Or equations, you have to graph it. And then for discrete functions, you just list them off.